Hello, this is Kennedy Kingston, and this is our data analysis project based on the series Game of Thrones. Today, we'll be discussing our hypothesis, our independent and dependent variables, the steps to take before running a regression analysis, and then finally, our results from both the correlation and the regression analysis. Our group is interested in finding the point where the Game of Thrones franchise began declining based on both the TV series and book series. When running any regression analysis, the two variables needed are the independent and dependent variables. In simpler terms, an independent variable is the influential variable that can be changed by the person or group analyzing the datasets. This variable can be characterized as continuous or discrete, meaning whether or not the variable can be counted. A dependent variable is the outcome of the changes made to the independent variables. Generally, all dependent variables must be continuous, meaning the variable can be counted and can take on any value within a range. In this specific scenario, our independent variables are the episodes and books in the Game of Thrones franchise. These variables are continuous since the episodes and books can be put into sequential order. And finally, our dependent variable is the total overall ratings of said books and TV shows. This variable will be viewed as continuous as well, since TV and book ratings are viewed numerically.
Hi, I'm Brooke Parker, and I'm going to talk about the steps to take before you run a regression. The first step is to analyze the data to make sure that there are no errors and that the data is adequate to run a correlation and a regression analysis. For our data, we inputted the numbers by hand to ensure that there were no computer errors that might have copy and pasted the numbers incorrectly. The second step is to make sure that the data is composed correctly. We had to place the information vertically so that the titles and labels are at the top over the data numbers. For our data, our titles included total ratings, episodes 1 through 10, and dummy variables for whether or not the seasons were adapted and based off of the books called A Song of Ice and Fire. We also had to not leave any blank spaces in any cells or else it would generate an error. In order to fix this potential error, you can do one of two things. Delete the rows that contain a blank space or input a 0 in the place of the blank space if it's appropriate. For our data, it had some blank spaces, so we chose the option of inputting zeros in those blank spaces instead of deleting the rows or columns entirely. Our blank spaces came from the fact that some seasons had less than 10 episodes, specifically in later seasons. Because there weren't episodes, there weren't ratings for those episodes, so inputting zeros in those places signify that there were 0 ratings for certain episodes because they did not exist. The third step is to run a correlation analysis once you are confident that your data is properly formatted. Correlation analysis identifies variables' relationships with one another and those relationships' strengths. If two variables are completely related, they have a correlation of 1. If two variables are not perfectly related, there are 5 classifications of variable relationship strengths. The first is a very high degree of correlation with numbers between 0.70 and 0.99. The second is a high degree of correlation with numbers between 0.50 and 1. The third is a moderate degree of correlation with numbers between 0.30 and 0.49. The fourth is a low degree of correlation with numbers below 0.29. And lastly, the fifth is no correlation with a value of 0. For our data, our correlation analysis had a lot of very high degrees of correlation, which are between 0.70 and 0.99. So we picked from the correlation values between 0.983 and 0.999, which resulted in 3 numbers that include correlations between episodes 1, 3, and 10, as well as not from the books. The fourth step is to finally run the regression. For our data, we use the variables that were most highly correlated with one another as our independent variables to run our regression.
Hey, this is Gabby. Correlation analysis is used when the regression analysis to help identify which independent variables highly correlate with a dependent variable. It is important to choose independent variables that are highly correlated to the dependent variables you choose. For this project, we use total ratings as the dependent variables and ratings of each individual episode as dependent variables. We use the correlation analysis to see just how correlated our independent variable and dependent variable were to each other. We also use the correlation analysis to ensure that the independent variables are not correlated to each other. When two independent variables are highly correlated with each other, this is considered multicollinearity. Episode 1 and Episode 3 are highly correlated with each other at 0.986861, while Episode 10 and Not From the Book is highly correlated at 0.992728.
Hey, it's Macy, and I'm going to be describing how we interpreted R squared and the ANOVA table in our regression analysis for the Game of Thrones. As you should know, R squared explains how much of the dependent variable is explained by the independent variables. Our independent variables were episodes and books, and our dependent variable was total ratings. The R squared we calculated was 99.24%. A high R squared is between 85 and 100%, and based off our calculation, we have a high R squared. This means that the independent variables in our model explain a higher percentage of the dependent variable. We then compared R squared to the F statistic in our ANOVA table. The ANOVA table helped us to determine whether we had a good regression equation. When evaluating the ANOVA table, we put our focus on the F statistic. The F statistic determines the ratio of explained variance to unexplained variance. A good F statistic value would be a value lower than 0.05, and our value came out to be 0.0016. Therefore, we had a good equation. We chose to run a second regression analysis because the p-values of Episode 1 and Not From the Books in our first regression were high. Episode 1 had a negative intercept, which is another reason why it wasn't significant. For some reason, the R squared value went down in the second regression to 98.58%. This could be because we improved the model by less than expected.
Hi, this is Emma Lewis. Step 3 of interpreting the regression analysis is to interpret the p-value of the coefficients in the table. The coefficients represent how much of the variable explains the dependent variable. Positive coefficients mean that the dependent variable increases as the coefficient of the independent variable increases, and negative coefficients mean that dependent variable decreases as the coefficient of the independent variable decreases. In our case, we only had positive p-values in this regression analysis, meaning that the total ratings increase as the coefficients of the episodes and books increase as well. Step 4 is to determine whether the coefficients of the independent variable are important and to evaluate using the p value. This is similar to the evaluation done using the F statistic. 0.05 or greater means you shouldn't use the variable. In our case, the variables in orange represent those over 0.05 and therefore showing not a significant relationship between the total ratings and both Episode 1 and Stuff from the Books. Step 5 is to use the equation to predict the dependent variables. Trying to see when the ratings started decreasing, we plugged in the values 25, 50, 75, and 100. But for the regression analysis 1, all those values stayed at negative 3.36. Since Episode 3 and 10 had a p-value of 0.05 or less, we ran a regression with these two variables for regression analysis 2. In that case, we also came up with the x values around negative 2,308, and then it kind of changed a little bit in the last few numbers of those, but they all kind of stayed around the same, meaning that there are no major drop-offs in the regression in either of the equations, which means there's not a point when the ratings start declining like we predicted in our hypothesis.
Even though we eventually got our data inputted correctly so that we could have a correct correlation and regression analysis, we did have a few difficulties. The first one was when we put seasons on top instead of episodes. This didn't work out with the rule to put data vertically, so we weren't able to see which seasons were most correlated instead of the episodes. Our second difficulty was when we put book adaptations together as one instead of separating them into two variables. The software wasn't able to pick up which zeros were intentional and which ones were inputted for blank spaces. The third difficulty we had was when we tried to put seasons and episodes together, like 1.1 for Season 1, Episode 1, with the ratings beside it. When we ran a correlation analysis on this, it gave us either very low numbers or no numbers at all. Thank you so much for watching our presentation on correlation and regression analysis.
Bye!